Clark, Director of Autonomous Driving and Safety Technology. Today, I'm excited to review a material set designed for semiconductor fabrication. We will review why semiconductors are important for present-day automotive, and we will look at the stresses associated to the package. From there, we will view the benefits offered by our conductive die attach product line. You will see it spans a wide range of thermal needs. As consumers, we have high expectations for vehicles and the overall travel experience. Automotive technology puts semiconductor design companies at the forefront of the supply chain. This is a departure from the past. Car makers and Tier 1s are collaborating and engaging in joint ventures with semiconductor companies to deliver capabilities which were not available in the past. Ultimately, the car maker needs to differentiate themselves from the competition. They are innovating where they never expected to. New players have market leads, and more players are arriving daily. Distinctive systems are enabled through electronics, but we must consider the harsh environments that exist in automotive. Today, innovation focus lies on two megatrends: advanced safety and electric powertrains. Some have described this as the beauty and brawn of the industry. The intricacies of advanced safety, including connectivity, bring miniaturized high-speed systems. Electric vehicles introduce a new power supply, and the vehicle architecture must find the balance to ensure success. The increased function and performance is enabled through the use of advanced semiconductor packages. But what is a semiconductor? Does it feel like an intimidating word or concept to you? Simply put, it's a material that conducts electric current sometimes, but not in all cases. Metal, like copper on the other hand, always conducts current. In most instances, the semiconductor is silicon. So an integrated circuit has an electric circuit etched into that silicon. This delivers function like interpreting instructions or storing data. The semiconductor package houses the silicon die. It protects that die and redistributes information in and out. We call this I/O, or input-output. Obviously, there are many different types of semiconductor packages. I'd like to focus on power electronics. Power electronics is a semiconductor used to control or convert electric power. It seems simple enough. So why is it a big deal? Well, it kind of goes back to that beauty and brawn. We have a new source of electricity in EVs, and this is high voltage. It must be converted for the more delicate applications outside of propelling the vehicle. We have a wide range of power needs, from safety to infotainment, and then also seat and lighting adjustments. I've said before that I consider the die the brain of the electronic system. We need to protect the brain, so packages are designed to do just that: encase the die and pull heat away from it. This thermal transfer path is important. Let's look closer at the parts of the semiconductor package. It starts with a support for the die. That will also redistribute information to and from the printed circuit board. And this can be an organic substrate, but for this discussion, we will start with a copper lead frame. The die can then be connected to the lead frame in many ways. Historically, it was done with lead-containing solder. As an industry, we want to move away from lead, but we also need better thermal properties when packages are used in extended circumstances. The industry moved to electrically conductive adhesives, or ECAs. They contained some silver to support thermal conductivity. Now, developments bring more silver into the adhesive and a specialized resin that promotes low temperature sintering without the need for pressure. I'll illustrate this in the upcoming slides, and overall, these formulas deliver higher thermal conductivity. So we see the adhesive is put down on the lead frame. This can be done as a film or a paste. The die is placed. Wire bonding may be used. And finally, the entire build is encapsulated with epoxy mold compound to protect everything. These high magnification images show the new offering is quite compelling. On the right-hand side, we see a higher concentration of silver in the gray areas. On the left-hand side, the black represents the epoxy, which does not have thermal conductivity. Unlike silver sintering, which is a fusion of silver particles that requires heat, time, and pressure, Atrox is a pressureless system. And this unique system creates two forms of attaching or bonding: chemical and silver sintering. A strong physical adhesion is important for harsh environments and for high heat packages. Let's look at the performance comparison to other technologies. We're comparing traditional leaded solder, the standard silver epoxy or ECA, and the Atrox product line. You can see the thermal conductivity is dramatically different. Atrox does not contain any lead, and there's no bonding pressure required. It simply relies on a heat profile to create a sintering mechanism. The other thing I want to point out is BLT, or bond line thickness control. Defined bond line thickness is an advantage of note. Unlike solder paste that will create a non-uniform bond layer after reflow, the Atrox material remains consistent. This is excellent for 5G and radar applications. So let's look closer at the performance data. In the table previously, we looked at bulk conductivity. Many companies will only report the bulk conductivity of their materials. It's not an accurate description of performance in a final build. It does not account for the die attach losing heat to other materials that it's connected to. Our internal testing delivers effective conductivity. This takes additional surfaces into the calculation and results in the expected thermal performance with a package build. You can view the stacked layers on the left. We see a significant improvement of the Atrox over both the lead solder control and the traditional electrically conductive adhesive. So the reality is these effective thermal conductivity numbers are realistic performances that you will get in your build. And I think that's important. We offer multiple material platforms, which gives us the ability to deliver a wide range of performance. We can match your design requirements. Our conductive die attach product line encompasses a range of thermal conductivity. Again, the beauty of this process is no pressure required. As the technology continues to advance, the systems will be required to have greater reliability, in many ways defined through thermal and mechanical stress resistance. Atrox is a proven process that will remove heat from the die in all design conditions. Ultimately, understanding how it performs within your semiconductor package will determine the expected characteristic life, but it is a necessity for advanced safety systems and many other power electronic needs. The process is easy and is considered drop-in solution for OSATs and OEMs alike, and there's no additional capital expenditure. Did you know this material is proven in vehicle use? That's right, we're already on it. Atrox can be found in the following production applications and still continues to find new roles in qualification builds. To make advances in your technology, you will need advanced materials that match your expectations. We have over 60 years experience in all market segments. We specialize in material development, and as a leading global supplier, we take pride in having a complete understanding of the automotive market's expectations and a strong focus on enhancing reliability. I want to thank you for your time, and I look forward to continuing this discussion with you. Please don't hesitate to contact me.